So the way that our Rube Goldberg project works is you start at this little marble tower right here. When you release this little elastic band right here, it hits all of these marbles, showing Newton's third law, equal and opposite reaction, and pushes this marble out, goes down a little teeter-totter, through all these little rails and through these little fans, comes down this ramp, and then the marbles will build up here until there's enough force moving the marbles to push one of the marbles through the 2-liter cap, pushing this golf ball, which will knock over these dominoes, which will then hit this golf ball, which will go down the ramp, go into our 2-liter funnel, down another ramp, show friction by hitting the dustpan, knocking over all of the dominoes. We'll go around through here, knock over those ones, it'll build up, hit that ball, go down the ramp again, and then do our simple task of rolling dice.
Elastic potential energy is shown by the rubber band that is stretched and held back by the clothespin. The law says the further an elastic object is stretched or compressed, then more potential energy it stores. So the farther it's pulled back, the more potential energy it has. Newton's third law is proven from the dominoes hitting each other and causing the equal or opposite reaction, which is whichever side the dominoes hit on. It leans on the opposite direction of impact. Friction is the resistance to motion when two objects are in contact with one another. This can be observed from the ramp wrapped with bubble wrap. The friction between the ball and the bubble wrap slows down the ball, which causes the ball to move slower. Newton's first law is represented by a tennis ball hitting the dustpan, as shown. It does this because the golf ball has a higher net force than the dustpan, which causes the dustpan to move in the direction of the net force, which will cause the dominoes to fall.